Hey guys, it's Caitlin, and I'm here to talk with you today about system of equations with circles. Why do we use system of equations with circles? System of equations with circles, like any other shapes, is used to find the intersecting points of the two bisecting shapes themselves. So for instance, in a Venn diagram, we have our two bisecting circles, and using system of equations, we could hypothetically find the two intersecting points of the two bisecting circles. Now, there are two methods that you can use to solve for a system of equations with circles. There is substitution and elimination. However, in this video, we are going to be focusing primarily on substitution. So the first step to any substitution would be to expand both equations, which may seem a bit tedious, but will help in the long run. Once you expand both equations, you can set them both equal to 0 by getting all of the components of the equation themselves onto one side of the equal sign and 0 on the other side. And since both equations are now equal to 0, you can set them both equal to one another. Once you set them both equal to one another, you are able to reduce until you get to a linear equation. And this linear equation is actually the equation for the line that goes through the two intersecting points of your circles themselves. Once you get this linear equation, you are going to want to set it equal to one of the variables. So for instance, let's say you have y is equal to 3x plus 6. And once you have this y is equal to 3x plus 6, you are then able to plug 3x plus 6 into any y that you see in one of the original circle equations. Once you plug the 3x plus 6 into one of the original equations, you are able to reduce to solve for x. And once you solve for x, which you will get two answers for, unless the two circles are tangent to one another, you can then plug this x into your linear equation to solve for y, and these x's and y's will be your two coordinate points that are the intersection points for your two circles. So now let's go to an actual example of a substitution with two circles. So we have the two equations, x minus 3 squared plus y minus 4 squared is equal to 4, and x minus 6 squared plus y minus 3 squared is equal to 10. The first step is to expand both equations, which is this step here, and then set them both equal to 0. Once you set them both equal to 0, you are able to set them equal to one another, and then reduce to get your linear equation. Once you get this linear equation and solve for a variable, you are then able to plug this back into your y's, and in this example, I plugged it back into my first original equation. And then that is the step here, us plugging 3x minus 7 into wherever we saw y in that equation. And then you are then able to algebraically solve, and then here is where we get to our square roots. So in this step, we get our x minus 18 over 5 squared is equal to 9 over 25. And then we take the square root of both sides so that we can solve for x. And in doing so, we get two answers for the square root of 9 over 25, because whenever you square root a number, you must get the positive and negative of that number. So now you get x minus 18 over 5 is equal to positive and negative 3 over 5, and that is where our two x's come from for our two coordinates. So we get our two x's, which is 21 over 5 and 3, and then we plug these back into our linear equation here, y is equal to 3x minus 7, and are able to solve for our y's, which is 28 over 5 and 2. And then Mr. Coulter likes them in fraction form, but determining on your matter of preference, you can either put them in fraction or decimal approximation. And so, for instance, you get 21 over 5, 28 over 5, and 3, 2 as your two coordinates of your intersection points, or as that translates into decimal form, 4.2, 5.6, and 3, 2. Now, if we look at a diagram of this, here are our two equations and our two circles. So we have this circle is the example of x minus 3 squared plus y minus 4 squared is equal to 4. And this equation is x minus 6 squared plus y minus 3 squared is equal to 10. Here are two intersecting points of 4.2, 5.6, and 3, 2. And then here is our linear equation that we found, which is y is equal to 3x minus 7. And that is how you solve for a system of equations with circles. Thanks so much, guys, and happy studying!